Today, we're going to do Law of Cosines. We haven't really talked about the fact that that's chapter 13, but it is. Our assignment I have put together, it's in your book, in your packet, as if it's two different things. I'm not doing it in 2 days. I'm doing it in 1 day. And so the whole assignment was on that one worksheet that you grabbed when you came in. To use the law of cosines to find the sides and angles of a triangle. All right, today, well, the first thing we're going to do is finding sides. So what do you do? Well, I don't need you to memorize all three of these. You really just need to know the pattern that does the law of cosines. So what I say, just like I did on law of sines, is just know this. When I said the area formula, I told you don't have to know it 3 different ways. You just have to look at the triangle and know what parts you need to be able to use it. So here's what you do to find a side. Okay, this is to find a side. I need a side, an angle, and a side. Then I can find the side across from the angle. Okay, so across or opposite, I should say, instead of across from, because in math we tend to say opposite side or angle or side opposite the angle to find a side opposite the angle. Okay, so if you understand what I just said there, if you have a side and an angle and a side, then you can find the missing side that's opposite the angle that you're given. Okay, so here's what this formula says. And once you know that pattern, they are all the same. So what I'm going to circle here is angle. Knowing angle A would be needed to do that first formula. So you'd need to know angle A, and you need to know side B and C. And then you'd be able to find side A. That's the whole law of cosines for finding a side. You can use it to find an angle as well, but I'm going to show you that a little bit differently. So let's do our first problem. Find the missing angles and the missing sides for each triangle ABC. I just drew a triangle here, and I'm going to label it a triangle ABC. Now, I am not telling you that all of these are equilateral. I'm just making a generic triangle, and it's not to scale. It won't be to scale, okay? So I'm going to plug in the stuff that's given. I got 58 degrees, and then you want to remember that the side called little a would be opposite the big A, okay, just like in that diagram here where it's showing that. Okay, so 18 would be opposite angle A. 11 would be opposite angle B. And what will we be able to find using this data? You'd be able to find this angle, or the side, opposite the angle that's given. So it would be side C that we can find. So that's going to be C squared will equal, now here's how the formula goes. It says take the adjacent sides to the angle and square them and add them. And then subtract 2 times their product times the cosine of the given angle between those sides. So this is side angle side. We've got 2 sides in the included angle. Then you can use law of cosines to find a side. Once you find that side, then you can use law of sines to do other stuff. All right, so I'm going to find other parts. So what we want to do is type all of this in our calculator. So I'm going to clear this out. 11 squared plus 18 squared minus 2 times 11 times 18. And then hit cosine. I forgot the angle. 58, thanks. All right, that gives us 235.1519, blah, blah, blah. Now, we have not finished the problem because that actually equals C squared. So I need to take the square root. So I'm going to just do it right now while I'm on the calculator, and I've got that answer. So I'm going to hit second, x squared, and then I'm going to hit second and pop in my answer right there. And I'm going to do that a lot today on these problems. So I'm going to use the number that's actually on the calculator from that calculation, and we'll have no issues with rounding then. So we're going to go to the nearest tenth, 15.3. Now this was 235, right? And then we took the square root, and we got C was 15.3. And that is in meters. Now, we are trying to solve the triangles, angles as well. So now that we have an angle and we know the side opposite it, we can use law of sines. So we're going to say the sine of 58 is 15.3 and now we're going to find, remember, we're going to use the smaller side to determine what angle we're going to find next, which is going to be angle B. Okay, so I'm going to do the sine of B is 211. All right, then I cross multiply, and I'm going to type 11 sine 58 divided by 15.3. 11 sine 58, and then I'm closing it, divided by 15.3. Now, this is the sine of B, so we actually have another step. So I want to go ahead and conclude it right now to get my answer. So what do I do to find this, get the sine of B to get the angle measure? Yeah, second. That's when you undo. So since you got a decimal, that's one of those ratios anyway. So it's saying the sine of B is the ratio of 0.6097, blah, blah, blah. We need to undo it. So we hit second, sine, and then I'm going to put that answer in. Second, negative key, but pops the answer you just had in. Hit enter. Now we got the angle measure of 37.6 degrees. So angle B is 37.6 degrees. How do I find the third angle? Well, that would be angle A. I'm going to ignore those blanks. So angle A would be 180 minus 58 minus 37.6, because I'm using the triangle angle sum theorem to get it. Instead of setting up another sine problem, you know, we can just do that. So what's that give you? Thank you, Caitlin. So angle A, you got 84.4 degrees. And there we go. We solved the triangle. Given 3 parts, we were able to find the other 3 parts. Try another one. I'm just going to label it ABC. I have a 100-degree angle B. Oh, that was convenient. That it's 100 degrees. That looks fairly reasonable. Actually, that's probably quite a bit more than 100, but regardless, we've got side A is 12. That's opposite angle A, so it'd be over here. On C is 13. That'd be opposite angle C, so it'd be over here. And we're going to be able to find side B. So B squared equals, take the adjacent 2 sides, 13 and 12, square them and add them. Subtract 2 times their product, 2 times 13 times 12 times the cosine of 100. Okay. Type that side all out and then take the square root. So 13 squared plus 12 squared minus 2 times 13 times 12 times the cosine. You don't have to hit the times button, times the cosine of 100. Okay, that's 367.178, blah, blah, blah. Take the square root. Oops, I hit the wrong button. Second square root of that answer. That would be 19.2. Do you care that I'm not writing down this number right here? I mean, I can do that if anybody's confused. At 367.178. Okay. All right, now find an angle. So right now we know B, which would be here, 19.2. So we can say the sine of 100 is to 19.2, as the sine of A is to 12. Do 12 times sine A, sine 100, excuse me. 12 times sine of 100, and then I can't write. You know what you're typing. Cross multiply and divide. So sine of A is going to be a decimal. You guys are probably ahead of me. I already got it. So I had trouble typing. All right, what was I dividing by? 13? And we got 0.9053? Or did I type that wrong? Oh, it's supposed to divide by 19.2. All right, I gotta look at my paper. I'm just gonna hit second enter and get that back. And I changed that to 19.2 so I have the right answer. All right, so this is what we're doing, the inverse sine of, second sine, put in that answer. I got 38 degrees. Okay, so angle A's measure was 38 degrees. Now, the third angle, which would be angle C, we'll take, you want to put it in that blank, I don't care. We're going to go 180 minus 100 minus 38, and that should be 42. Any questions right now? You should definitely be calculating away with me. Your calculator isn't open. You're not doing what you ought to be doing, honestly. You really need to practice typing this stuff in. It helps you remember what to do. Yes. Okay, it can get to be a little different, and that really only occurs when one of the angles is obtuse. That's why we start with the smaller side. Find the angle opposite the smaller side when we do the law of sines. Because if it happens to be an obtuse angle, there could be two answers. Your calc might not give you the one you need. Because remember how all right, briefly, the sine wave goes like this. So there's like two places where there's the same answer, like here and here, for y. And I'll show you those, talk to you a lot more about that when we start doing the unit circle. Okay, so let's do this on ABC. C40 would be opposite angle C. A is 62, and then B was 56, little b. All right, so we're going to be able to find side A using law of sines. So A squared equals 40 squared plus 56 squared minus 2 times 40 times, why did I write that there? I'm going to run right into that triangle. Okay, you guys know what I'm about to type, right? I guess you guys are typing away. Fabulous. Guess see if I can squeeze this in here. Cosine of 62. Okay, I've already typed that in, and I know you guys are ahead of me, so let me catch up. I'm going to tell you that that was 228. Wait, this is number 3. Sorry, I'm looking at the wrong one. Can you tell me what you got on your calc when you type? It was 2,632 point, and then it went 767, blah, blah, blah. Okay, take the square root of that. You should have gotten 51.3, and that would be in inches. Anyone got a problem with that calculation? You need to be doing it so that you're knowing if you're getting the right answers. All right, now that I found that, I can say the sine of 62 is to 51.3 as, I'm going to find angle C, as the sine of C is to 40. Sorry, that looks like an 8. It's a sine. Okay, so I do the cross products. 40 sine 62 divided by 51.3. Okay, and that would be 0.688458. All right, but we need to take the inverse sine of that to find the angle measure. Got 43.5 degrees. Okay, you need to put degrees on your angles and labels on your measurements, your length. So we're going to find the third angle. In this case, it will be angle B. So do your triangle angle sum theorem, 180 minus 51.3 minus 43 point, oh no, sorry, I said the side. 180 minus 62 minus 43.5. Okay, and when I did that, I have 74.5 degrees. My pen is absolutely stuck. Oh, there we go. Oops. Thinking something here. Not what I gotta turn this off a second. I'm gonna pause. Okay, I had students go ahead and do number 4, see if they could do it by themselves. So the thing isn't working again. I turned it off, started over. All right, so you should have had it set up. Oh my gosh, why is that disappeared? I can't see it. This is 15 down here, and you guys found A. All right, so let me tell you that A was 15.1, and that was all you had to find. We're good? And that was in B. All right. Oh, on the other side, number 5, find the missing angles and the missing sides. I'd like you to try that one, please. No blanks filled in for you. We've just got to go for it. You'll be finding side C first. This is a long thing to type in. So you should be doing 22 squared plus 35 squared minus 2 times 22 times 35 times the cosine of 42. Okay, you got 564 and take the square root of that decimal answer, leaving it in the calc. Okay, so we got 23.8. Okay, once you know that, then use your law of sines. Sine of 42 is to 23.8 as, I'm going to find angle A first. The sine of A is to 22. Okay, cross products, cross multiply and divide. So I got 22 sine 42 divided by 23.8. And then you need to take the second sine, inverse sine of that. And I got 38.2 degrees. And that's angle A. And then angle B, we'll do 180 minus 42 minus 38.2, and that should come out to 99.8. Okay, there's one more there. Why don't you go ahead and do it, and we'll check the answers. Okay. Does anybody need help with this one? All right, go for it. Oh, I might even skip it. Yes. What did you want? It's okay. This one? Okay. Did you have any questions on it? So which one were you missing? Okay, did it come out differently? That's why we want to start with the smaller. How big? That's because of what I said before, that you don't, okay, you need to do the smaller one because there's actually two values that have the same sign value within 2 pi radians. I'm going to be explaining more about all this later. So that's what the rule is right now. You need to go with the smaller side when you're doing law of sines first. And when you're doing the law of cosines, we're going to find out in a minute because we're going to find angles that we're going to need to use the larger angle when we're finding the angles in law of cosines. Okay, so you got that fixed now? Now, and I could explain why, but I really can't yet because it's not like the time within the unit for me to tell you why there's two answers. I kind of showed you. And again, I can say it again. The reason is because over the course of, this is 0 degrees, this is 180 degrees. Between here and here, there's two answers that are the same. That's because of the symmetry of the curve that it makes. All right, let's go on. For 6, because I asked you to go ahead and do that, can I just check if you got the answers? So you should have found B, and you got 140.5 centimeters. Okay, and then your angles, angle A, 26.7, and angle C, 33.3. Okay, let's go for that word problem. The Perth County Pool has a lifeguard station in both the deep water and the shallow water sections of the pool. The distance between each station and the bottom of the slide is known, but the manager would like to calculate some more information about the setup of the pool. When the lifeguards switch positions from the deep water station to the shallow station, the deep water station swims to the shallow water station. How far does the lifeguard swim? So that would be the distance from here to here. So we want to find that. We can use our law of cosines. So x squared, the distance we want to find, would equal 18 squared plus 12 squared minus 2 times 18 times 12 times the cosine of 38 degrees. So here's an application. And if you type that all in your calculator and take the square root, guys, do it and see if you get what I'm going to say. Letting you all practice on your calc. When you take the square root of that big number you get, should be getting 11.3. All right, and that would be in yards. Do we need help with that one? It's just sometimes it's like we just make a boo-boo typing, All right, if the lifeguard at the deep water station is directly facing the bottom of the slide, so he's looking that way, what angle does she need to turn in order to face the lifeguard at the shallow water station? So we want this angle right here. Okay, we've already found out that x is 11.3, so we can say the sine of 38 is to 11.3 as the sine of the angle we want to find. I'll just call it D because it's a deep water station. Sine of angle D is to 12. Right. Cross multiply and divide, and you should end up with 40.8 degrees after you take the second sine. All right, am I okay? If anybody needs me to type it in, I will, so you can see what I'm typing. I'll be doing 12 sine 38, close that parentheses, divide by 11.3. All right, one more application. Oh, she's skating. During a figure skating routine, well, figure skating just ended in the Olympics not long ago. Jackie and Peter skate apart. Okay, so Jackie's going and Peter's skating, and there's a 15-degree angle between them. So Jackie skates for 5 meters. That was Jackie. And Peter skates for 7 meters. There's Peter. How far apart are the skaters? So we want to find this. Okay, so we do our law of cosines because we have two sides in the included angle. So x squared would equal 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15. All right, you guys finish that one off, and I will get ready for finding angles. I forgot to write the answer down on that. You want to tell me what it was? About 2.5 meters. Any problems on that? No. Okay. That was just a very repetitive, type of problems where we're doing the same kind over and over. So I hope you don't mind. I kind of went a little quick, and I expected you guys to do a lot of calculating. That's the whole point. It's like you memorize the formula just by the fact that you did all that calculating. Here we go. Law of cosines continued. We are doing, this is on 8A. Now we're going to figure out some angles. And I'm going to tell you again, I am not, actually, you can do this two ways. Some teachers teach it by using just the same formula. I like to do it solved for cosine A. So that's all it is one of these formulas. The first one actually, solved for cosine A. So what would happen is, and I'll just explain it if you want me to show you how we get that formula. So I don't care if you choose to use, that was 2bc times the cosine of A. So the way they solved it was they did a squared minus b squared minus c squared, and then they divided by negative 2bc, and that would give you cosine A alone. Okay? So then they applied the negative sign to the top, which gave them c squared plus b squared minus a squared all over 2bc. That's where it came from. Okay, so let's just do this, and I'll show you the pattern for how to do it. Some teachers don't show this formula at all. I just prefer it because, I don't know, it's just the way I've always done it. If I look at this triangle, what would we actually need? So if we're going to find angle A, that's what we would be finding. What we would need is all three sides. Okay, so to find an angle, you need all three sides to use law of cosines. Okay, so we would need this, this, and this in order to do finding angle A. Or any of the angles. I don't even have to write. You need all three sides. All right, so let's do one. So little a is, let's label our course some triangle. I know you guys have to draw one quick. Triangle ABC with side little a across from big A, 22, B, 19, and C, 14. Now, it says use the biggest number and find the matching angles. So we want to look at the biggest side length, and that would be find angle A. Okay? So we're going to do cosine A, and it would equal, so since I'm going to find angle A, I'm going to start off with the adjacent sides to that angle in the formula. That's what you start with, just like you do in the other formula. You take those adjacent sides first, and then you subtract the one across from it. So you go 14 squared plus 19 squared minus 22 squared, divided by 2 times the first two that you started with, the 14 and the 19. Now, I would like you to type the numerator and denominator separately. At least that's how I'm going to do it. Because otherwise, if you do all this, it's so easy to make a mistake in how you type it in that you may end up just making, errors. And you're going to get a decimal, and it's going to be some long decimal anyway. Okay, I'm going to clear this out. So we had, I believe it was 14 squared plus 19 squared. And then we were subtracting 22 squared. And then we are going to write down that number. All right, that was 73. Now I'm going to do the bottom. 2 times 14 times 19. And the denominator, so then I'm going to copy this down. I'm going to write 73 over 532. And so now I'm going to say the cosine of A is 73 over 532. And so we want to find the angle. So we're going to do angle A is, you're going to type the inverse cosine of 73 over 532. So hit second, cosine, put in the 73 we found first, which was the numerator, divided by the denominator 532. Okay, and that's 82.1 degrees. So angle A is 82.1 degrees. Now, we found angle A. Now I can use law of sines to find the rest of the angles. So, I should find which one first. Use the, now we found the first by using the larger angle. Now we're going to find the smaller one, okay? So we'll do C first. So let's do sine of 82.1 is to 22 as the sine of C is to 14. Now we're using law of sines. We're going to find the smallest angle. Cross multiply, and I'll go ahead and type it. 14 sine 82.1. Close that up. I forgot what I'm dividing by. 22. Okay. And then I need to do second sine of that answer. 39.1 degrees. So angle C equals 39.1 degrees. And now we'll use triangle angle sum theorem to find angle B. So you're just going to go, oh, that would be angle B. You're going to go on your calc and do 180 minus 39.1 minus 82.1. Or you can add those together first and then subtract it. When I did it, I got 58.8 degrees. Okay, let's try number 2. I don't like these triangles. I make my own, since you have to. Okay, so first thing I would do is draw a triangle. Nice little sloppy triangle. Label angle A, side A. Label angle B, side B. This is so not to scale. C and 27. Not to scale at all. Oh well. But what I'm going to find is angle A because it's opposite the largest side. Okay, so I look for the largest side, find that angle. So cosine of A equals, since I'm finding angle A, I'm going to need to start with 27 and 14. 27 squared plus 14 squared minus 39 squared. All over 2 times 27 times 14. Okay, type that numerator. Yep, that's, yep, we're going to get a negative. Plus 14 squared minus 39 squared. Okay, so my numerator is negative 596. I'm going to go ahead and type in so I can see what my denominator is going to be. 2 times 27 times 14. Okay, so I've got negative 596 over 756. And I take the second cosine and I put those numbers in. Negative 596 divided by 756. That finds me the angle of, oh, I typed something goofy. I hit cosine twice. That's so not right. I wonder if I even used the negative key. I don't know. Oh, must be the end of the day. All right, 756. All right, did you guys get 142 degrees? Okay. Now, angle A is obtuse, 142 degrees. We have an obtuse angle in this triangle, and we wanted to know that. Okay, so that's why we found the biggest angle first. How did I get what? I said second cosine of negative 596 divided by 756. I did this. Okay. You all right now? Okay. All right, now we're going to find the rest of the angles. The next one, since we're using law of sines, which one are we going to find? Which would be opposite the smallest side, so angle B. So I don't care if you want to start sine of B is to 14. You need to use the sine of 142 is to 39. Okay, so 14 sine 142 divided by 39. Okay, I got 12.8. Oops, forgot to hit the button. I'm going to have to undo the second sine of that. 12.8 degrees. To say my triangle is not to scale is an understatement. Okay, find the missing angle C. I'll just do my triangle angle sum. So that's 180 minus 154.8. You should be getting something with a 2 at the end. 0.2. Let's see, what was it? 25.2. Okay. Ooh, this one's kind of nice because look what's going to happen. What kind of triangle is it? Even though it's not drawn like one. It is isosceles because C is 10 and the other two sides are 7. It would have to be an isosceles triangle, which means two angles are the same size as well. Because boom, boom. What do we start with? We need to start with angle C. Okay, because it's opposite the 10 degree, the 10. So we're going to do cosine of C. That will equal, now work with the 7 and the 7, subtract the 10. So we have 7 squared plus 7 squared minus 10 squared. Is anybody not understanding why I'm doing 7 and 7 first and then subtracting 10? That's the formula where it says do the adjacent to the angle you're finding. Okay, first, and then divide by 2 times the 7 times the 7. Okay, we're going to get 49 minus 100. So that's going to be another one with a negative in the numerator. And that's just negative 2. Because that's negative 98 minus 100. And on the bottom, we're going to get 98. So second cosine of negative 2 divided by 98. Find that angle to be 91.2 degrees. Okay, I guess we are still solving the rest of the triangle, so we'll start with the sine of 91.2 is to 10. You could for this case, because you know that these are equal angles. Yes, and that is only because it's isosceles. Yep. So you do 180 minus 91.2 and divide that by 2. Yeah, why not? Then I divide that by 2. But anyway, I'll continue with just doing my sine. So I can just do one of them though. So the sine of A is to 7. Okay, 7 sine 91.2 divided by 10. Oops. Okay, I'm just going to quit. So on that, because it's 44.4 each, right? Okay, so angle B and angle A are 44.4 degrees each. You have like 2 minutes. Stop it. There isn't really anything new on the other side. It just asks you to find particular angles. If you understood what we're doing, we'll be all right. And I'll do a few more things on this on Monday. You got a book page to work on, and we'll have some time to work Monday and Tuesday and ask questions about the ones you're having trouble with, especially like word problems and stuff.